Okay, this problem concerns the following game. We roll 3 dice. I pick a number. If my number appears, then I win $1 for every time that my number appears. But if my number does not appear, then I lose $1. So let n be the number of times the number appears. Then n is going to have binomial distribution with parameters 3 and 1/6. There's 3 dice that are being rolled. Each die has a 1 chance in 6 of the number appearing. Okay, so n is not x, but n is certainly related to x. I lose $1 if n is equal to 0. I win $1 if n is equal to 1. I win $2 if n is equal to 2. And I win $3 if n is equal to 3. Now these 4 probabilities are computed using the binomial distribution. So 3 choose 0, 1 6 to the 0, 5 6 to the third, and that's 125 out of 216. This one is 3 choose 1, 1 6 to the first, 5 6 to the second, and that's equal to 75 over 216. The third one is 3 choose 2, 1 6 to the second, 5 6 to the first, which is 15 over 216. And the last one is 3 choose 3, 1 6 to the third, 5 6 to the 0, and that's 1 over 216. So those are the 4 probabilities and the possible values. And the possible values that I really care about are the values for x. The values for n I use to get these probabilities, but now that I have these, the ones that I really care about are the values for x. So the expected value of x is equal to -1 times 125 over 216 plus 1 times 75 over 216 plus 2 times 15 over 216 plus 3 times 1 over 216, and that should be equal to -17 over 216. Next, we have to figure out the standard deviation. To figure out the standard deviation, we first figure out the expected value of x squared. So that's -1 squared times 125 over 216 plus 1 squared times 75 over 216 plus 2 squared times 15 over 216 plus 3 squared times 1 over 216, which equals 269 over 216. So the standard deviation would therefore be equal to the square root of 269 over 216 minus -17 over 216 squared, and that's approximately 1.11318. So that's the expected value and the standard deviation for playing the game once. Part 2 of the problem, we play the game 100 times and let y be the total winnings, figure out the expected value of y and the standard deviation of y. So y is equal to the sum of 100 playings of this game. So from one of the theorems in class, the expected value of y would be equal to 100 times the expected value for x. So that's 100 times -17 over 216, which would be approximately -7.287. And the standard deviation for y would be equal to the square root of 100 times the standard deviation for x. And so if I multiply the standard deviation for x by 10, I get 11.13 approximately. So, and of course the units here are in dollars. So if I play the game 100 times, I expect to lose $7.87, give or take $11 or so.